Hey guys, I'm Shreyas, and today we're in the second day of the August LeetCoding challenge. And the question for today is to sum. So we're given an integer array and another integer target. We have to find two elements of this array such that they add to the target, and we have to return the indices of those two elements. And for given input, there's only exactly one solution. So the solution is unique, and so we have to just return the indices in any order. So there's one more constraint that we cannot use the same element twice. They have to be different elements. So the first thing that comes to our mind in such kind of problem is that to run is the brute force solution where we run two for loops and just check if the addition of two numbers is equal to target value or not, and if yes, we just return the indices of those two numbers, something like that. But the time complexity of that approach is O of n square. With the limits of 10 power 4, it might barely pass all the test cases, but we are looking for a better algorithm with the complexity less than n square. And so for a particular element in the array, we are just looking for any other element which has a value of target minus the value of the current element. So if I'm at 7, I'm searching for some other element in the array which has value of 9 minus 7, that is 2. So that is how the dot process is going. But in the earlier approach, we used to run another for loop to search the second element. So in order to retrieve the second element faster, so we have to do it. We should not run another for loop, and we have to have a faster retrieval of those values. So in order to do that, I'm using a hash map in this problem where I'm marking the particular element's value with the index of wherever it occurs. And so if I'm at particular position I, so let me explain with the code, it becomes easier then. So I'm just going from the back to the start. It can be any way, and I'm using a hash map over here for retrieving for getting the element's position. So for a particular element, I'm just searching if there is any other element with the value target minus the current element. So if it is present, then I have found out the two elements value which add up to the target value, and hence I'm inserting the current index and then the index of the second element, which is stored in the hash map. And then since the answer is unique, I got the answer, then I break out of the for loop and return the array. And if we have not found the answer, then we just map the array value to the index for the future reference. So at the most, for within n iterations, we'll be able to find the answer and return the index of those two elements. So this is how, by using a hash map, we can reduce the time complexity of retrieval from O of n to O of log n. If we use an unordered map instead of map, then the retrieval happens much faster. On an average, it happens in O of 1. So in that case, the time complexity is further reduced. But if you're just using a map, the time complexity would be like O of n log n, which is much better than O of n square. So, and the space complexity in this approach is O of n because the map consumes space for storing the index. So yeah, that's it for the video, guys, and thanks for watching.